All right, we're going to be looking at the problem of merging two sorted arrays. So if you haven't seen this problem before, it's kind of neat because perhaps intuitively you would expect merging two lists and maintaining the result being sorted would be something like combining them and then sorting them, which would be on the order of n log n. But actually, if the inputs are already sorted, you can do this in linear time. So it's kind of a neat trick. Ultimately, the way that it works is you kind of walk through these two arrays at the same time. And at any point, you just take the value that is smaller, move it to your merged output, and then keep track of the fact that you're going to start consuming from one further in that array. So for example, we're merging the lists A and B, and we're kind of consuming from the very beginning initially. At this point, we can see that they're both equal, so it doesn't actually matter which one you take. We'll just say we'll take A initially. So we'll take one from A, and the pointer for A moves forward one. Now we're looking at 1 and 2. 1 is smaller. We move that forward, and so forth. We're going to take the 2, move this forward, then we take the 3, then we take the 4, then we take the 5. And here is kind of a special case where we've already consumed one of the arrays. We'll see this more in the actual code implementation, but at this point we can basically just consume from the remaining list. So we'll just put down 6 and 7, and that's it. And like I said earlier, the running time of this is linear over the length of both lists, because essentially we only have to consider each number once, which is why merging when they're already sorted is kind of faster than having to combine and then sort the entire results. And space complexity is also just proportional to the length of the summed lists, because the only new space that we needed was the space for the results. So that's it. We'll go ahead and look at some code. All right, let's take a peek at the code. Here, A is one of the lists that we want to merge, and B is the other one. And notice that they are both already sorted. Out is where we are going to save our generated list that is the merging of these two inputs. AI and BI are both pointers to the next element to be consumed from A and B respectively, and we'll see how this gets used in the main loop. So we have 3 loops here. The bulk of the algorithm actually exists in this one, and these two are kind of to handle like a cleanup case that we'll explain more in a little bit. So we essentially merge these two lists as long as the pointer for the first element that has not yet been read from each list is in bounds. And the merging logic is we compare the smallest element left in each list, and if the one from A is smaller, then we append that to output, and then we walk forward the pointer on A. Otherwise, we add the element from B and move forward the pointer on B. This will make a lot more sense when we watch it run. And then merging ends when we have fully consumed one list, but the other list will still have some elements. And ahead of time, we don't know whether or not we will finish consuming from A first or B first, because it doesn't depend on the length of the list, but it just depends on which element is larger in each of the lists. So the cleanup case, this basically handles there being extra elements from the A list. And just like we did above, all it basically does is, as long as AI is in bounds, it will consume from A and then move that pointer forward. The second loop is basically the same for B. And in practice, we'll only run one of these. I'll call it out when we start stepping through it, and you can better understand what this is. And then finally, at the end, we just return the merged output. So there's a quick run through. Let's watch it work. So here's one list, and here's the other. As I said, AI and BI are always pointing to the next element in these respective lists. You can also think about it as the smallest element that hasn't yet been appended to out. So now we're starting our merging list. In this case, they are equal. So just for simplicity and to make sure that this covers everything, we take from A if they are equal. So we're going to append that 1 from A to out, and then step forward our A pointer. So now we can also think about this as we're merging this list with the entirety of B. Continue. This time the smallest element is from B, so we take that and then move B forward. And we kind of just continue stepping forward one step at a time from each of the smallest lists. Here we have B being smallest, so we step forward B. Here we took from A. Here we took from B again. There we took from A. Okay. We have one more left. Great. So at this point, we have fully consumed A. Notice that the AI pointer has basically disappeared because it would be pointing out of bounds. So now we're checking to basically clean up to make sure that we have fully consumed the two input lists. We have nothing from AI, so this one won't run. We do have an element left from BI, and we could have had more elements. This will essentially copy all the remaining elements in B to the end of output. There's the 7. And in practice, if we had more elements, it would continue here, copying them all to the end. And that's it. So here we have our merge list. That is the result of merging A and B. I hope that helped. Looking forward to seeing you all on the next video.